Section 6.3, example 11, finding the Taylor polynomials. So the Taylor polynomials, we're going to find P1 or P naught, P1, 2, and 3 for f of x is equal to ln of x at x equals 1. So use a graphing utility to compare the graphs of f and their polynomials. So Taylor series is helping us expand on this here. So finding a different function or a set of polynomials so that we could see what this graph here looks like. And right over here, we have our Taylor series. So if f has derivatives at x equals a, then our Taylor series is going to mimic this right here, or is this right here. So we're starting off, so it's the sum of all of these different values, the sum of our nth derivative of f evaluated at a with our factorial. So for the very first one, since n starts off at 0, our first factorial is going to be 0, so 0 factorial. And we just keep increasing here. So here we have our original function, our first derivative, second, all the way up to the nth derivative, depending on where we're stopping. I believe in this example, we're stopping at 4, but these go on infinitely, so forever. And yeah, so then at the bottom we have our factorial. So 1 factorial for the first derivative, 2 factorial for the second derivative, so on and so forth. And also x minus a to its power. So for the very first term, we have x minus a to the power 0, or we're just multiplying by 1. For the first derivative, we have x minus a to the first power. And for the nth derivative, we're matching it with x minus a to the nth power. So that would be somewhere over here. So let's grab this information and take it over here. All right, so starting off with this, let's get a little guide. So the largest one, we're just up to 3. So the largest one we're going to find is to the power 3. So let's get a little guide for that. So the third polynomial is starting off with the original function evaluated at a. So f of a over 0 factorial times x minus a to the power 0. And for these, we already have different values. So we have a is equal to 1. For the meantime, we'll just leave it as this. So that's going to be the 0th term. The first derivative evaluated at a, 1 factorial, x minus a to the power 1. For the third part, we have f double prime, or the second derivative, matched with 2 factorial, matched with x minus a to the power 2. And lastly, because we're looking at the third polynomial, or P3, so plus f, we're looking at the third derivative evaluated at a, 3 factorial, x minus a to the power 3. That's our third polynomial. So parts that are really easy to see, we could just write them in. X minus a, or in this case, x minus 1. See the whole question. X minus 1, so a ends up being 1, so we know that for sure. We don't have to do too much work there. Our factorials, it's as simple as throwing it in a calculator, or the highest one we go to is 3. That's 3 times 2 times 1, which is just 6. So we have that. Something that we have to kind of plan for are going to be our derivatives. So let's start with that. So f of x is equal to ln of x. And we're going all the way up to the third derivative. So we have f prime, the second derivative, and the third derivative. So the first derivative is going to be 1 over x, or we could write this as x to the negative 1. The next one is going to be negative x to the negative 2, positive 2x to the negative 3. To make it a little bit easier, let's evaluate all of these at a. Remember we said a is 1, so x is equal to 1. So from here, let's match all of these with us evaluating each of these at 1. So f of 1 is going to be 0. F prime of 1 is going to be 1. F double prime of 1 is going to be negative 1. And triple prime evaluated at 1 is going to be 2. So it looks like we have everything that we need. And all we have to do at this point is plug everything in. So first derivative, or first polynomial, P1, P2, and up to P3. So for our P1, it's just going to be this very first term, which is our f of a divided by 0 factorial, which is 1. And this part is 1. So we're just looking at f of a. F of a is 0. So there we go. That's it. For polynomial 1, we have 0 plus the second part. So our first derivative matched with 1 factorial matched with x minus 1. So f prime of 1 is 1 over 1 factorial times x minus a, which a is 1. And that's it for our P1. Yeah, P0, P1, P2. We're looking at all of these values again. This time we're adding in this term here. So f double prime of a is negative 1. So negative 1 over 2 factorial, which is 2 times 1, just equals 2 x minus a squared. And that's it for polynomial 2. Polynomial 3 is us adding all of this together. So 0 plus, we could kind of just copy all of these here. 1 over 2, negative 1 over 2, x minus a, actually not a, 1 squared. And lastly, we have this term. The third derivative evaluated at a is 2 over 3 factorial, that's 3 times 2 times 1, which is 6. And then we have x minus a, or in this case, x minus 1 cubed. And just so we have a better visual of each of these, our first polynomial is just 0. Our second polynomial, we have 1 divided by 1, which is 1, so we just have x minus 1. The next one is going to be x minus 1 plus this right here. X minus 1 minus 1 over 2. X minus 1 squared. And lastly, we have all of this. That's 0. This is just x minus 1 minus 1/2 x minus 2 squared. And we could simplify this last part. X minus 1 minus 1 over 2, x minus 1 squared, plus 1 over 3, x minus 1 cubed. And let's see what else I wanted us to do. So we found each of these. So use a graphing utility to compare the graph of f with the graphs of these over here. So just a sec. Okay, here we go. So here we have our functions. So P0 was matched or is equal to 0. So that's this function right here. And the next one, P1, x minus 1 is this one here. We just have that line. Notice that we have like it equal to 1 at this point. And let's take a look at this next one. Our second polynomial, so P2 is this somewhat lengthy one. So x minus 1 minus 1 over 2, x minus 1 squared. That's what we have here. This ends up being a like parabolic shape because it's degree 2. Degree 3 is going to be a little bit different. So it's going to be a cubic function. But all of these are centered right here at y equals 0 and also at x equals 1. So all of these are equivalent at that one point. And even more here, we have this blue function. You could barely see it. Let's kind of see what this looks like here. So this is our original function, f of x is equal to ln of x. And we have all of these other approximations, but notice that as we get larger and larger values or larger polynomials, we start getting a lot closer to that blue graph right there, to our original f of x is equal to ln of x. And there we go. That's our Taylor polynomials. If you have any questions whatsoever, please feel free to ask. Otherwise, bye.